All right, so let's do IXL 7th grade DD.14. I am at IXL. I'm going to click on Learning and then scroll down to 7th grade and then down to DD. Here's DD.14, the counting principle. All right, so the counting principle is a very important principle for probability. Probability meaning we're talking about the chances of some event occurring. And before we do the question here, I'm just going to go to frydmanmath.weebly.com and let's read the section of the reference page having to do with the counting principle. So probability is on page 11. So I'm going to scroll down to page 11. Let's find that. Here's page 9. And here is page 11. The page numbers are in the top corner of each page. So here it says page 11 in the top right corner. On some of the pages, the page number is in the top left corner. So if it's an even numbered page, it'll be in the top left corner. If it's an odd numbered page, it'll be in the top right corner. So here's page 11. Don't look at this. Or if you do look at this, then you have to subtract 2. So we're on page 11 now. Probability is right over here, and it's sort of an L-shaped section. Here's the counting principle over here, and it says to find how many combinations there are, multiply the number of ways each thing can happen. Okay, multiply the number of ways each thing can happen. For example, the number of different combinations of outcomes of flipping a coin, which has 2 sides, and rolling a number cube, which has 6 faces, is 2 times 6, which is equal to 12. Okay? So what does that mean? If we have a coin, let me draw a coin over here. Let's say that's a quarter. Now, a coin has 2 sides. It has one side is heads and one side is tails, right? And a number cube has 6 faces. A number cube just means a die, like, when you play Monopoly, you roll the dice. Die is singular for dice. So a number cube or a die has 6 faces, and they're numbered 1, 2, 3, 4, 5, 6, right? So here, the different outcomes for flipping a coin are heads or tails. And the different outcomes for rolling a number cube are 1, 2, 3, 4, 5, and 6. Now, what if I wanted to flip the coin and then roll the die here? What might happen? Well, I might get a heads from the coin, and I might get a 1 from the die or the number cube. Or I might get a heads and roll a 2. Or I might get a heads and roll a 3. Or heads 4, heads 5, heads 6. So far those are 6 combinations, but I also might flip the coin and get a tails. So I could get tails on the coin, and then I roll the die and I get a 1. Or I could get tails 2, tails 3, tails 4, tails 5, or tails 6. Okay, so those are all the possibilities. those are all the different combinations that I can make with heads and tails for the coin, and 1, 2, 3, 4, 5, 6 for the number cube. How many possibilities are those? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 total possibilities. And what I just did over here was I made an organized list. That's also on the reference page. If you look at representations over here, what we could do, just like what I did over here, is we can make what's called an organized list, which is you just list all the different combinations. Or you could list them all in a table, which is basically the same thing as an organized list. It's just written a different way. Heads 1, heads 2, heads 3, etc. You could also make a tree diagram. You can see over here, you can say heads, tails. I'll do it over here a little bit bigger. If I wanted to make a tree diagram listing all the possible outcomes, then I could say, well, I could get heads if I flip the coin, and after I get heads, I could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Or I might get a tails, and after I flip the tails, I could then roll the die and get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And once again, how many different combinations do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this one here means I flipped the coin and I got heads, and then I rolled the die and I got a 3. This one over here means I flipped the coin and I got tails, and then I rolled the die and I got a 3. But all in all, there are 12 different ways that this could happen. Now, if I don't want to go through all of the trouble of writing an organized list or drawing a tree diagram, is there a faster way that I can figure out that there are 12 different combinations of doing this? Well, yes, there is, and that's what we talked about over here in the counting principle, which is we could just say, okay, I know the coin has 2 sides, and I know the number cube or the die has 6 faces. So if I want to know the number of possibilities, the number of different combinations, all I really need to do is 2 times 6, which equals 12. Right? Again, there are 12 different combinations: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And to figure that out, I can just multiply the number of different ways that this might occur of flipping the coin with the number of different ways of rolling a die, the number of different outcomes. Okay, so getting back to IXL over here, Bruce is designing a bathroom. There are 2 different bathtubs and 10 different sinks to choose from. How many different bathrooms can Bruce design? All we have to do to figure out the different combinations of putting together 2 of these different bathtubs and 10 different sinks, how many different combinations can we make from 2 different types of bathtubs and 10 different types of sinks? We'll just do 2 times 10. Just do 2 times 10, which is 20. That's it. Okay, so just take the numbers and you multiply them to figure out how many different combinations there are. And if I jump to the next level here, if I get a question like this, well, this one actually looks, the numbers are the same as the last one. Becky is a high school senior applying to a particular art school. All students who want to attend this art school must send in a portfolio that meets very specific requirements. The portfolio must have one black and white drawing and one color drawing. And Becky has 10 favorite black and white drawings and 2 favorite color drawings to choose from. Assuming the order of the pieces doesn't matter, how many different portfolios can Becky send to the art school? Again, we're just going to do 10 times 2, okay, which is 20. Okay, and this works even if there are more than 2 numbers here. So if I have 8 types of eyeshadow, 2 types of mascara, 3 types of concealer, and 2 types of lipstick, how many different combinations of eyeshadow and lipstick and concealer and mascara can I make? Right? Let's say if I wanted to, well, not me, I don't usually wear lipstick, but if somebody wanted to wear something different every day, have a different outfit every day, then how can we figure out how many different combinations of lipstick and eyeshadow there are? Well, there are 8 types of whoops, why am I writing 2? There are 8 types of eyeshadow. And what else did it say? 2 types of mascara, 3 types of concealers. So times 2 times 3, and 2 types of lipsticks. Okay, so what would that be? You can use a calculator for this. That's okay. 8 times 2 would be 16. 16 times 3 would be 48, and 48 times 2 would be 96. I hope I got this right. So there should be 96 different combinations there. Yeah, there we go. Okay, I'm going to try a different type of question. I'm going to jump ahead here. And, okay, this type of question looks the same as the last one. Let's jump ahead to the, what are they called? The challenge section? Okay, so again, it's all the same. So we're just taking the numbers and multiplying them. That gives us all the number of different combinations you can make. Okay, have a great night.